Welcome to My Clean Diesel and our 17th WebEx on diesel exhaust fluid. What is it? What does it do? And how to care for it? Jim Doyle and Paul Click are your hosts for this, and we're going to explain all the intricacies of diesel exhaust fluid.
All right, the objectives for today are the definition of DEF, diesel exhaust fluid, and its function in your exhaust system. How to eliminate crystallization. You may have heard about crystallization of DEF fluid, and we'll talk about what forms it and how to manage it. Material compatibility is also very important with DEF fluid. It's fundamentally much different than fuel or oil you're using on a piece of equipment. And best ways to eliminate contamination in fluid. So what is diesel exhaust fluid, or DEF? Mainly it's water. It's 67.5% ultra pure water, so reverse osmosis water, no minerals of any kind in it, just ultra pure water, and 32.5% lab grade urea. So this is a very specific chemical mixture to use as a reactant in a reaction in the exhaust system. It doesn't mix into the diesel fuel. It doesn't go through the cylinder. This is dosed in as a chemical reactant in a gas coming out the exhaust side of your engine. So that's what makes up 100% DEF. All of the different versions of it you see are made of this exact same mixture. It's very highly controlled, unlike fuels and oils, which are a blend of a whole bunch of different things. So DEF has a pH of about 9.5. Just to give you an idea, water is a perfect neutral 7. Ammonia is 11.5. And bleach is 12.6. So DEF is a little on the basic side, but it's not really aggressive. It's not dangerous to handle or anything. It's just a little bit on the base side of things, not acidic, but base. Because of that 32% urea ions in the water, it drops the freezing temperature of the mixture to 11 degrees Fahrenheit, so it doesn't freeze at regular freezing, but it does turn into a block of ice if you do let it get cold in northern climates. It must be kept free from contamination as well. As said, it's a very specific chemical reactant of ultra pure water and a very pure chemical being mixed in with that, and it cannot have debris or dirt in it, even at the levels of really clean diesel fuel and that kind of thing. It must be kept very. So gone are the days of the big black smokestacks and rotten egg smell belching out of the trucks as you're driving down the highway, or people drop the hammer and out comes the big black smoke. Those days are gone for diesel engine performance for the vast majority of equipment in service now. The traditional simple diesel cycle is air comes into the compressor side of the turbo, it gets compressed, it gets cooled back down, and it gets rammed into the cylinder. Fuel gets sprayed in, piston comes up, and whatever happens. Everything burns. It burns as completely as it bothers to in the cylinder. Exhaust valve opens, out it goes, spins the turbine on the other side of the turbo, and goes belching out the stacks like black smoke and soot coming out the other end. So that's the brutally simple diesel exhaust air cycle, the air coming in and exhaust coming out, and things have changed an awful lot from that time. So here's a diagram of the incoming and outgoing air of the engine itself for a modern high pressure common rail or tier 3 or tier 4 engine. There's a compressor on the inlet side. Again, air comes in through the air cleaner, particulate is removed, it gets compressed. It gets cooled back down as a charge air going to the engine, but it encounters something called the EGR valve, and that adjusts the charge air mixture. So there's a certain amount of oxygen in the air coming to the engine that's needed for combustion, and part of the regulation of what goes on in the cylinder and how completely the fuel is burnt and what goes on there is accomplished by recirculating some of the exhaust gas, cooling it down and recirculating it back in and blending it back into the engine to control the amount of oxygen there and the mixture of chemicals coming in that gas. to get complete combustion coming out the other side. You're trying to get the maximum efficiency of burning the fuel in the engine here to not generate much soot, because we still need to manage soot as the exhaust leaves the engine. So as it comes out the engine side, it goes and spins the turbo again, just like before, and then it goes out the exhaust. And that's where things are just getting started on a modern engine. It's not just going out the stacks like on the pictures before. So here we have the exhaust airflow and all the components in a modern high-pressure common rail diesel engine that meets the newer standards, Tier 3 and Tier 4 here in the US in particular. You'll see there's the little red dot there on the engine itself over there on the left, and it says NOx and PM, and that's oxides of nitrogen or NOx, and particulate matter, and that's mainly soot. There's also a couple other things that come out of there, carbon dioxide and carbon monoxide. Carbon monoxide is dangerous to breathe, and it is really powerful greenhouse gas in comparison to carbon dioxide. So they come out the cylinder as the engine is running, and you come to your first stage of treatment. We'll get back to the HC doser there in a minute, but you come to the diesel oxidation catalyst. And what that does is that converts any carbon monoxide, it oxidizes it to carbon dioxide, so it's a less harmful greenhouse gas coming out the exhaust system. So you've done that there, and then you enter what's called the DPF, or the diesel particulate filter, and that's where all your soot collects. So you want to create as little soot as possible in the engine so you don't overwhelm the DPF. If your engine is not burning the fuel efficiently, it will create a whole bunch of extra soot, and it will plug the diesel particulate filter more quickly than you want it to, and you will start to do what's called regen cycles. And regen cycles are nothing more than diesel fuel, a hydrocarbon, being dosed into your exhaust system at the HC doser there up by the turbo, and that increases the temperature in the exhaust system to burn the soot that's in the diesel particulate filter out and regenerate it. It'll give you a loss of power. That restriction will give you a loss of power, and regenerating the engine is not at its maximum performance either. You want a system that keeps that diesel particulate filter in service and not restricting for as long as possible. So you need to maintain that efficiency. And that is basically related to the fuel system side, the liquid fuel feed side of the engine, and that's a whole nother complex cycle. So after you've got carbon monoxide converted to carbon dioxide and you removed all the soot, you still have the NOx, or oxides of nitrogen, passing on through your exhaust system. That material passes downstream, or that gas passes downstream, and that is where the diesel exhaust fluid, or DEF, is dosed into your exhaust system. The liquid is sprayed in through an injector nozzle into the system, and you are now going to run a chemical reaction between the diesel exhaust fluid and the oxides of nitrogen. The DEF solution hydrolyzes into ammonia gas, which mixes with the exhaust system there in the exhaust tube, and you now come a final step to the SCR catalyst in your exhaust system. That's selective catalytic reduction catalyst there, and it converts the ammonia into nothing more than nitrogen and water. So out the exhaust comes the carbon dioxide, water, and nitrogen. And the atmosphere is 80% nitrogen, so you're just putting a gas back in that is just like the gas that's already in there. Obviously there's a lot of water in the atmosphere and carbon dioxide coming out the exhaust system. So it's a very complex process downstream of the engine compared to just belching soot out the stacks as was done previously. So what components are in the system besides those pieces in the exhaust system, the selective catalytic reduction section there and the particulate filter, etc. There's a tank that has a big blue cap on it for DEF on every new vehicle. It's a plastic tank. It has a heater in it to keep you above that 11 degrees Fahrenheit to prevent icing, and it's made of a bunch of somewhat more exotic materials than the rest of your engine and fuel system, for compatibility reasons, and we'll touch on that in a second. On the right there is a picture of a DEF tank that had a leak, and that mixture of urea and water, if the water evaporates, it leaves the urea behind, and it's a crystalline white material like you see there. That you want to avoid. It will go back into solution in water inside the tank, but you will get this crystallizing on dispenser nozzles and on sort of handling equipment occasionally, and you really want to avoid that. If it goes back into the water, it'll dissolve in, but you don't want it building up. This happened to be a tank that had a leak, and it crystallized a whole bunch of it on there. Just a nice example to look at. But the DEF tank there has a membrane breather to keep any particulate out of it in service as it goes down the road on a truck or something, and has a cap on there to seal, to isolate it after you've filled with a DEF dispensing system. Earlier I mentioned the material compatibility issues, and material compatibility for a DEF is quite a bit different than it is for the rest of the fluids on an engine system or hydraulics. Compatible materials would be stainless steel, 304 or 304L or 316 stainless. Hastelloy, that's a very exotic material. That's basically using the injector into the exhaust system. It can take the temperature and still run the injection process nicely. High density polyethylene or HDPE plastics, polypropylene, glass, PTFE membranes, EPDM gasket materials, Viton gaskets, and in comparison, epoxy potting there, I guess, as well. In comparison, things that are not compatible are an awful lot of materials that everything else in the engine system is made of. Carbon steel, zinc-plated steel, iron, aluminum, copper, brass, PVC, and typical Buna gasket materials. Those are all not compatible. So if you take some sort of fuel or oil filter and think you're going to be filtering your diesel exhaust fluid, you're going to have some serious corrosion and compatibility issues to deal with. So it's a very dedicated set of equipment for handling and delivering this material.
So speaking of storage and handling practices, obviously, be working with reputable pump suppliers and fluid distributors to get the best products available. Here's an example of diesel exhaust fluid in a storage container, 300-gallon tote. Now, the only other thing too is DEF degrades in sunlight, so it's usually a good idea to try and put a UV barrier between your tank and any outdoor installations. And here's another example of a smaller 50 to 100-gallon tote dispensing unit, chemically compatible pump. There's a few manufacturers that would make them, and then on the bottom left you see a stainless steel Donaldson filter, and we're hitting 1 micron high efficiency particle filtration. A lot of our competitors are in the 30 to 40 micron range, and again, as Jim explained, the composition of diesel exhaust fluid just being a combination of urea and water. There are no contaminants when it's manufactured. Any form of contamination allows for that crystalline formation to happen, and the whole idea of filtering the bulk fluid is to remove any potential contamination before it goes on the equipment and actually causes downtime and more expensive failures. So we're doing 1 micron high efficiency particle filtration, and trying to keep all the debris out of that diesel exhaust fluid.
Other potential cross-contamination issues, it does occur infrequently, but for instance, coolant is a water-based mixture of water and glycol, and someone may try and handle DEF with the same materials that they're handling their coolants with. That seems like it might be sort of a potential reuse of equipment or something. And about the worst chemistry you could add to this solution is the glycol in your coolant. That will foul the catalysts in the exhaust after treatment system, and those are by far the most expensive components. So if you were to do that, use a coolant container to dump DEF into a system, or run coolant through the system and then switch over to DEF. you're going to be buying new exhaust catalyst components at very high prices, and you don't want to do that. So we're doing the high efficiency filtration here to do anything we can to try and catch issues before they would cause a problem on vehicle. You'll also notice on this dispenser system here on the barrel, there is a breather on there. That is a typical silica gel type breather. It is a decent particulate filter, but consider that that's basically a tank full of water, and you're trying to manage water going in and out of that with a breather. There's really no point. The barrel's full of water no matter what, so because the fluid is water-based anyway. So that's, you basically have to do good particulate defense there with something that's compatible with DEF. So plastics and that kind of thing are more the order there, unless you can find something in stainless steel.
So here's just a cut sheet on the DEF filter assembly. A few components or highlights that we'd like to make. This unit is engineered to handle about 10 gallon minute max dispense rates, which would be sufficient for about 95% of all applications. Obviously, there's some higher volume users that might need to go a little bit up to the 20 gallon per minute range, in which case you just have to install 2 of these and plumbed in parallel. Now remember, all plumbing and fitting connections going into this stainless steel head should be made out of stainless steel or other chemically compatible material with diesel exhaust fluid. The filter is sold separately, and when you are replacing, typically it's a good idea to use some grease to lubricate the O-ring, and in which case on the next page it's a silicone-based lubricant used to that's chemically compatible with diesel exhaust fluid. So that's all we had for the presentation. There's ample information in the industry on all things related to diesel exhaust fluid and diesel for cleanliness for high pressure common rail engines. Stay connected with us at mycleandiesel.com. Scroll down to the bottom of the page, put your email in, and we'll automatically update you on any future WebExes.
Thanks for listening.